Hello, my name is Mike, and this presentation is about native C extensions in RubyGems. I'll explain what a native extension is, but then I'll focus in on a particular challenge for C extensions, how to safely and reliably use third-party C libraries, like libyaml or libxml2. I want to show you simple working examples of 3 different approaches to using third-party libraries. One of those strategies, pre-compiled extensions, is extremely powerful but tricky to do well. I'll show you how to do it, and then we'll discuss the risks and benefits. After watching this talk, you'll know better when and how to write and package your own C extensions, and you'll understand the difficult trade-offs being made today by Ruby C extension maintainers. What is a C extension? Well, I like to think that we create extensions every day, simply by writing Ruby code. Should I extend Ruby to have a class named Mike is great? Okay, here it is. I've extended the virtual machine with a new class. That's not so hard. A C extension is the same thing, except we write our code in C rather than in Ruby. Here is that same extension written in C. That's a little more complicated, but not too bad. The problem is, MRI can't read that C code directly. We have to first get it into a form where it can be required like any other Ruby file, and this is where it can get challenging. We have to first compile that C code into an object file, and then go through a process known as linking to combine it with Ruby's C library, and only then is it in the correct form to be required, which is what we call a shared object. Let's look at a simple gem I've created named Isolated. So named because it is entirely self-contained and doesn't call any third-party libraries. You might choose to write a C extension like this as a performance optimization if you have some CPU-intensive work to do. The bcrypt gem is a good example of this kind of C extension. It's iterating over cryptographic math, which is simply faster in C than it would be in Ruby. The isolated gem contains a little bit of C code to perform some CPU-intensive work. This is just like our Mike is great example, but now with an additional singleton method defined. Because it's a small extension, it compiles and installs rather quickly. And when we peek at the directory where the gem has been installed, we see a file named isolated.so. That's the C extension. It's the final compiled version of our C code, and it gets required by isolated.rb, just like any other Ruby file. Now, there's quite a bit happening to make even a simple gem like Isolated install smoothly. Let's walk through what happens during gem install, step by step, from the source code all the way to the shared library. Here, I've got the isolated source code checked out locally. The gem spec tells us where in the project we can find the extension directory. That extension directory contains all of the C code as well as the extension configuration file, which is always named extconf.rb. Now, extconf is a Ruby script, and it has one job, which is to write a precise recipe for compiling and linking the extension. In the case of Isolated, the extconf is as simple as it gets. mkmf is short for make_file, a Ruby module that's shipped with the standard library. It defines create_makefile, as well as a handful of other methods for advanced configuration, some of which we'll see in later examples. The create_makefile method is what actually writes the recipe for compiling and linking. Because we haven't configured anything, it's going to adopt a set of reasonable defaults. The first section of our output recipe will be compilation, and by default, create_makefile will compile any C file in the current directory. So our recipe will start out looking something like this. That reads, please compile isolated.c into the object file isolated.o and make sure to include Ruby's header files. If we had more C files, each would be compiled individually into a similarly named object file with a .o on the end. The recipe will also contain a second section, which is to link the object files with all of Ruby's C libraries and create the shared object. So this command reads, please create a shared object by combining our object files with Ruby's library and the system's C and math libraries. This recipe is written out by create_makefile in the form of, unsurprisingly, a makefile. Let's run this script and take a look at the results. Make is the great-grandparent of rake, and it is commonly used to manage recipes like this with many steps. We're not going to look very hard at the makefile today, but it's good to know that create_makefile has done a lot of work for us. It's taken the generic high-level description in the extconf and turned it into a rather long but precise recipe. We can also see that this makefile is specific to both my CPU architecture and operating system, but also the minor version of Ruby that I'm running. The extconf is generic, but this makefile will only work on a Linux x86 64 system running Ruby 3.0. Now, finally at the end of our journey, we'll run make, and we'll see that it's compiled and linked our code, and we have the final shared object we expected, isolated.so. As I mentioned before, a shared object can be required by Ruby as if it were a Ruby file. And once it's required, we can verify everything worked by calling the method we defined in our C extension. Congratulations! We've extended Ruby by writing some C code. Okay, now go ahead and run gem install rcee isolated and verify yourself that everything works perfectly. So let's summarize what just happened there with the gem install. Step 1, the gem utility downloads the gem file and extracts it. Step 2, the gem spec declares where the extconf file is. Step 3, the extconf file generates a makefile. Step 4, the make utility compiles our code. Step 5, the make utility links our code and generates that shared object, which is then just required by the gem like any other file. I mentioned earlier that one goal of a C extension might be to optimize performance. This is the case for bcrypt. But there's another more common reason to write a C extension, which is to talk to a third-party library. The reason I'm giving this presentation is because I've spent a lot of time over the past few years working with third-party libraries and calling them from Ruby. I've been the primary maintainer of Nokogiri for over a decade. Aaron Patterson once called me Nokogiri Mother in a conference talk, and I kind of liked it. If you're not familiar, Nokogiri is a Ruby library for parsing XML or HTML documents. The formal specifications for XML and HTML are huge. It would have been a monumental task to implement all of that from scratch in Ruby, and I'm pretty lazy. So instead, Nokogiri relies on existing open source libraries and interacts with them through a C extension. Many RubyGems use C extensions solely to integrate with a third-party library. Some examples are Psych, SQLite 3, RMagic, gRPC. You can probably think of one or two others. Most of these gems have a thinnish wrapper of Ruby and C that work together to make the library's features available as idiomatic Ruby. You might be wondering if a C extension is the only way to call third-party libraries. Heck no. The other popular method is Ruby's Foreign Function Interface, or FFI. FFI allows Ruby code to call libraries directly, without the need to use a C extension as an intermediate layer. FFI is a powerful tool, but choosing when to use it, that's a topic for another talk. Things can go wrong when installing a C extension, even relatively simple ones. If you want proof, here's a search for old bcrypt installation issues. Now, this isn't bcrypt's fault. I'm not trying to blame them. So let's talk a minute about what can go wrong on the user side while they're building a C extension. The first thing, users need to have a compiler toolchain. That's the compiler, the linker, a make tool of some kind, and they need appropriate system header files and libraries. Now, this is such a common problem that the Nokogiri documentation site has a separate section just on getting those basics installed. Most Linux distros will offer a meta package like Build Essentials that will take care of this for you. On Windows, the Ruby community is very lucky to have Lars Canis, and before him, Louis Lavina, maintaining the Ruby Installer Dev Kit that ships a version of Ruby along with its entire integrated toolchain. This is great stuff. On macOS, you've got the Xcode command line tools, which come with their own installation problems. Users also need a working Ruby development environment. This isn't usually a problem for folks who've already installed the C toolchain, but it can be a hurdle for newbies, particularly when error messages are vague like this. Finally, your users will need a consistent environment. Once that gem is built, your C extension can only run on that architecture, that minor version of Ruby, with those system library versions. You can't copy your gems from your Mac development machine to your Linux production server, and you can't upgrade Ruby and still use the gems you installed previously. Okay, enough talk. Let's do this. For the next few minutes, I'm going to show you a series of gems that each illustrate a different way to integrate with a third-party library. These gems are going to escalate in complexity, but each will build on the previous one, so we'll get there in small steps. All of the code I'm presenting here is available in a GitHub project I started named Ruby C Extensions Explained. Here's a short link for it, so if you want to follow along, please clone the repo and feel free to run this on your own system. All these gems actually work. Some gems, like SQLite 3 and RMagic, require that the user install third-party libraries on their system ahead of time. We'll call this the system strategy. I've created a gem named RCEE System to demonstrate how to find and use a library that's already installed. The library we'll use for all of these examples is libyaml. Looking at system.c first, we're calling the YAML getVersion function and returning the result in a string. That's pretty simple, but it's enough to demonstrate the integration works. Looking at the extconf, it's very similar to the isolated gem, except that it has a new stanza, find header and find library. These are helper methods, which will search your system's standard directories looking for files, and if it finds them, it'll make sure that the compile step will pull in the header file and the link step will pull in the library. We specifically ask makefile to look for yaml.h because that's what our C code includes. And then we also ask it to look for a library named libyaml and check that it has a method YAML getVersion because that's what we're calling. Now, we don't need to do this for every C function that we call. We just need to provide one method from the library so that find library can successfully test that linking will succeed. So if all that went well, the recipe will look something like this. You'll see in the compile line, there's an additional directory for header files. And in the link line, there's a directory for a library and -l YAML, which says pull in libyaml. On most systems, though, everything's installed in standard directories, and this gets simplified a bit to this form. Let's run through this process manually before we try to install the gem. Oh, snap. I don't have libyaml installed. Let me go Google for a few minutes and figure out how to get past this, and we'll come back and try again. Okay, we're back. I've got it installed. I'll now run the extconf, generate a makefile. I can see that extconf is there. I'll run make. I'll generate a system.so. I can see that it's actually got a reference to libyaml.so in there. Which means that I can probably require it, and I can run our method and call our C function, demonstrating that all of this works. That's fantastic. Go ahead and install RCEE System yourself. You can see that it takes a little bit longer than the isolated gem did, but not too bad. So great, everything worked. What tends to break about the system strategy? Installing third-party libraries can be frustrating for users, as we just saw. Different systems may install libraries into non-standard directories. You may get a newer or an older version of the library that you didn't expect. In the case of like SQLite, there may be features that are compiled or not compiled in to that library that you need, and you need to handle all of those. So maybe you as a gem maintainer are okay with these trade-offs. In which case you need to improve your documentation so that installation works. You need to handle edge cases in your extconf for different installation directories, and you need to add complexity to your code in order to handle features being turned on or off. This can get really challenging in the real world across a lot of different platforms. Take a look at the RMagic or the SQLite 3 extconf files if you want to see exactly how ugly this can get. So if you're not okay with these trade-offs and you decide you want a more reliable installation experience, or you want to guarantee a specific version of a library, have I got a strategy for you. Some gems, like Nokogiri and Psych, package the third-party libraries C files. This means the gem is redistributing the library, so be careful with licensing implications if you do this. Packaging third-party libraries is a little more work for gem maintainers to set up, but it may simplify your codebase and make installation more reliable. The easiest way to package up external libraries is simply to drop the source files into your extensions directory. I've got another gem, packaged source, ready to show you. The C code is the same as our system gem, so the only difference is where we're getting libyaml. Looking at the extensions directory here, you can see a new subdirectory containing all of the C and header files from libyaml, along with the license. Make sure you understand the legal implications of redistributing. The new code in our extconf does the following. vpath tells makefile to look at the YAML subdirectory. We add all of the source files explicitly, and then we tell makefile where it can find libyaml's header files. Looking at our sudo recipe, now the compile phase will do something like this. We have an additional -i argument for YAML include, and each file is listed individually. The link phase is going to be identical to the system gem, except with more object files. Running through this manually, we see everything is working as expected. That was easy. Go gem install RCEE packaged source and see that, it takes a few seconds longer than system, but it does work. It takes 8 seconds, and system took something like 3 seconds. So this strategy works pretty well for simple cases, but looking at the recipe, we can see that there are some limitations here because the libyaml code is being treated as if it were part of our Ruby C extension. That's limiting because the same compilation step must be shared across the extension and the third-party library, and we need to be careful about file name collisions between the two file sets as well. So many third-party libraries have their own build process based on tools like autoconf or CMake. For those libraries, it might be really challenging to just copy the C files and let makefile compile them. In those situations, it is possible to package the entire upstream tarball and use that at installation time. So once again, I've got a working example named packaged tarball. Looking at the project directory, we can see a new directory named ports that contains the upstream tarball for libyaml. An important tool I want to introduce here is miniportil, which is an API to take a tarball of source code and compile it into a library we can link against. This was created by Louis Levina many years ago. So the new bit in the extconf is this miniportil block. It's pretty busy to look at, but let's try to break it down. We download the libyaml tarball, we verify the checksum, and we extract the files from the tarball. We configure libyaml's build system, and we compile it, and we link the object files together. And then finally, we configure makefile to find the headers and the library. This last step is one of the advantages of using a standard autoconf distribution. You can usually leverage package config to set all of your compiler and linker flags, and that makes your extconf pretty clean. So when we run extconf, we'll see that all of that is happening to build libyaml before the makefile is created, so that the compile and link steps will know how to find what we just built. This is different from the package source where it was all built by the makefile. Everything works. If you go run gem install RCE package tarball, I'm not going to do animated GIFs anymore because it's starting to take a long time. This takes 18 seconds. That is significantly slower than packaged source. And that's because Miniportil is running additional compilation steps to build the library. Now, the benefit of packaging source like this is that maintainers can rely on a known version of the library being available, which may simplify both your code and the installation process. But the downside, the meh here, is that maintainers now have an additional responsibility to keep that library up to date and secure for your users. Now, some gems, like Psych, adopt a hybrid approach to give users an option to either use the system library or fall back to using the packaged version. Finally, as our gem install timing demonstrates, packaging a third-party library as a tarball can take significantly longer to install than using the system or packaged source strategies, because it's going to go through that additional configuration step. Nokogiri 1.11 was the first version in which we shipped pre-compiled libraries for most major platforms. That's Windows, Linux, and Mac OS, both x86 and ARM. Along with the Java extension, the pre-compiled gems account for 45 million installations. That's over 95% of all Nokogiri installations this year. Would it surprise you to know that I'm able to do all of this from my Linux machine? It's a true story. Let me introduce you to Rake Compiler Doc. Maintained by Lars Canis, this introduces a Docker-based build environment that uses Rake Compiler to cross-compile for all of these major platforms. Essentially what this means is I can run the normal gem build process in a Docker container on my Linux machine, and I get Windows and Mac libraries. This is really powerful stuff, and once we assume that we can cross-compile reliably, the remaining problems boil down to modifying how we build the gem file and making sure that we test adequately on all platforms. So once again, I've got an example gem set up to show you. It's called precompiled. It is a straight copy of packaged tarball that we've modified a little bit. So the first modification is the extension task, which was very simple, but is now big and hairy like this. Let's break it down. We've got some local variables declaring which versions of Ruby and which platforms we want to cross-compile to. We set an environment variable to let RakeCompiler know what we're doing. We signal to RakeCompiler to turn on cross-compiling features and create some additional rake tasks. We have some code here to signal to our extconf that we're cross-compiling. And finally, this block only runs when we're cross-compiling, and we use it to modify the gem spec and remove the stuff that we don't need in the native gems. Next, we have a couple of new rake tasks to coordinate the work being done in the Docker container. The idea is I run the top task on the host, and the bottom task gets run inside the Docker container. You'll notice that the worker in the Docker container is both compiling the extension and packaging the gem using the gem spec that was just modified by our extension task. Let's look at the changes being made to extconf. We've added a couple of lines to make sure that we use the cross-compiling compiler and not the normal compiler. This is where we check the flag passed to us. We don't use this, but it's a useful technique to know that we can pass into our extconf the information about when we're cross-compiling. And the rest of the extconf changes are related to configuring libyaml at build time. So we need to set the fpic option so we can mix static and shared libraries together. That should probably always be set. And then the subdirs environment variable is something that's very specific to libyaml. It tells the libyaml to turn off the tests during the build, because although we can compile binaries for Mac OS, we cannot actually run them. We have one more small change to make before we wrap this up. But first, we need to take a look at the layout of the finished packaged gem. You can see that we have 4 C extensions in this gem, one for each minor version of Ruby that we want to support. So remember, the C extension is specific to an architecture and a version of Ruby. So if we're running Ruby 3.0.1, we need to load the extension in the 3.0 directory. Let's make sure we do that. In our precompiled.rb, it used to look like this. It now looks like this. And what we're doing is we first check to see if the precompiled extension file is present. If it's not, we'll fall back to the compiled version, the version that's presuming that it was installed, compiled during installation. That's it. That's all it took to upgrade packaged tarball to precompiled. Although one note is that we still also need to build that vanilla Ruby version for people who aren't on Linux, Mac, or Windows. I'm looking at you, FreeBSD people. That whole process of building that gem is unchanged. You still do it with just a rake gem or a gem build. So go ahead and try it. Gem install RCE precompiled. If you're on Windows, Linux, or a Mac, it'll install in like a second, and everyone else will take a few more seconds to basically install the packaged tarball. This strategy isn't perfect. Remember what I said earlier, that a compiled C extension is specific to a Ruby version, the platform, and the system libraries. Precompiled strategy mostly takes care of the first two, but there are still edge cases around system libraries. The big gotcha is that Linux libc is not the same as Linux musl, which is Alpine Linux, and we've had to work around this a few times in Nokogiri. I am positive that there are more edge cases that will be found as users add more platforms. I'm also willing to bet money that you could break this by setting some Ruby compile time flags on your system. I'm honestly surprised it works as well as it has. So the lesson here is make sure you have an automated test pipeline that will build a gem and test it on a target platform. This takes time to set up, but it will save you time and effort in the long run. What's next for me? I would love to expand on this project. I would love to include a lot of the information here in the README there. I would love to extract some of these precompiled patterns into a gem to make it more accessible, and I would love to work with gem maintainers who are interested in precompiling any of their gems, so reach out, please. I want to say thank you to Luis, Lars, Kuhei, David, and Aaron. Without you, this would not have happened. Thank you.